Apollo was created by Apptronik, an Austin, Texas robotics company spun out of work at the University of Texas at Austin's Human-Centered Robotics Lab. The core team includes engineers who previously worked on NASA projects, notably contributions to NASA's Valkyrie program, and a decade of prior robot designs that culminated in Apollo. Apptronik's leadership and engineering approach emphasize building humanoid hardware that is mass manufacturable, safe for close human interaction, and economically viable for industrial customers, a strategy that guided Apollo's development from lab prototypes to the alpha units we see today. Apollo was publicly unveiled by Apptronik in August 2023 after several years of iterative development and testing that drew on earlier platforms and research prototypes. The company presented Apollo as the practical next step in humanoid machines. Instead of pushing extreme agility as an academic exercise, these engineers focused on repeatable tasks in human environments, warehouses and factories, and built the robot with commercial deployment in mind. Since the unveiling, Apptronik has continued rapid engineering iterations and entered partnerships, for example with NVIDIA for AI integration and with manufacturing partner Jabil to scale production, demonstrating that the design moved from concept to production intent across 2023-2025. At its core, Apollo's main features and specifications reflect a human-scale, industrially focused humanoid. It stands roughly 5 feet 8 inches, approximately equals 1.7-1.73 meters tall, weighs about 160 pounds, approximately equals 72 to 73 kilogram, can carry a payload in the neighborhood of 25 kilograms, approximately equals 55 lb, and runs on a swappable battery pack for roughly 4 hours of operation per charge. The robot includes expressive, human-friendly elements, big circular eyes, formed by stereoscopic cameras, a small e-ink mouth display to show simple expressions or status, and an OLED chest screen for conveying information to coworkers, all packaged into a form designed to be approachable while remaining functional in industrial settings. Apollo is described as general purpose, in the sense that its hardware and software are intended to support a wide range of manual tasks, such as case picking, kitting, line-side delivery, pallet handling, and other intralogistics operations. The body structure and materials used in Apollo reflect that industrial commercial emphasis. The chassis and limb structures are engineered for strength-to-weight efficiency and manufacturability, using a combination of machined and molded structural components, internal frames and housing panels designed for mass production, and modular interfaces to support different end effectors or mobility bases. The external surfaces and displays are arranged to be durable in factory environments while remaining safe and accessible for humans working nearby. Apptronik describes the design as intentionally mass manufacturable, which means choices about materials, fasteners, and subassembly processes are driven by scale considerations rather than bespoke, hand-built parts. Public materials and imagery from Apptronik and partner descriptions emphasize the modular, production-oriented design rather than experimental exotic materials. How Apollo works ties together its mechanics, sensing, compute, and control. Mechanically, Apollo uses electrically driven actuators at joints designed for high torque and force control architecture for safe human-robot interaction, and modular wrists hands to manipulate boxes and fixtures. Sensor suites include stereoscopic cameras for vision, depth sensors, and in some descriptions lidar or depth cameras for environment mapping and obstacle avoidance, and force torque sensing integrated into limbs for compliant manipulation. On the compute side, Apollo has onboard high-performance AI compute. Apptronik has stated Apollo integrates NVIDIA Jetson AGX Orin and Jetson Orin NX modules, so that perception, planning, and control can run with low latency on the robot itself. Apptronik is also collaborating with NVIDIA's Project GR00T and other AI efforts so the robot can learn from human demonstrations and generalized tasks. The software stack blends real-time control loops for balance, locomotion, force control and safety with perception modules and higher-level task planners and learning models that translate demonstrations or prompts into sequences of motions. The robot's friendly operation is enabled by a force-aware control architecture that behaves more like collaborative industrial arms, which yield or limit force around people, than the stiff, high-speed industrial manipulators that are unsafe for close proximity. On the question of price and estimated cost, Apptronik has not published a firm retail price for Apollo units because the company has been focused on pilot deployments, production scaling, and partnerships. However, the company and press interviews have repeatedly signaled a target price that aims to be less than the price of a car, and company statements and reporting suggest a target on the order of tens of thousands of dollars per unit in volume. Public reporting and industry commentary frequently cite an internal target near $50,000 per robot as a future goal for scaled production, while acknowledging early prototypes and limited run units will be far costlier and the true unit economics depend heavily on production volume and supply chain scaling. In short, no official list price today, but target economics announced quoted publicly center around approximately equals $50,000 per unit ambition once mass production and supply chain efficiencies are realized. Apollo's country of origin and primary development hub is the United States. The company is based in Austin, Texas, and many of the publicly described R&D and initial manufacturing development activities have been US-centered, though Apptronik has announced global manufacturing partnerships, for example Jabil, and commercial agreements with international firms such as Mercedes-Benz that point to a global deployment and production footprint. So, while Apollo is American-designed and developed, the production and deployment ecosystem is intentionally international. The future benefits and applications for humanity that Apptronik and industry observers emphasize are largely practical and social. In the near term, humanoid robots like Apollo are expected to perform physically demanding, repetitive, or hazardous tasks in warehouses, manufacturing floors, and logistics hubs, tasks that currently cause workplace injuries or require long shifts doing low-complexity work. Freeing humans from these physically intensive chores could reduce injuries, improve productivity, and allow human workers to move into higher-value roles: supervision, quality control, maintenance, product design, customer service. In the medium and long term, proponents envision extensions to elder care, healthcare support, construction, working in environments already designed for humans, and even space operations where humanoid form factors are advantageous. Beyond labor substitution, Apollo-class robots could provide societal benefits by addressing labor shortages in aging societies, assisting in disaster response, or enabling new service models where safe physical robots are needed. Apptronik's collaborations with large industrial partners clearly target these kinds of applied outcomes. There are several hidden or less-known facts and design choices worth mentioning. Apollo's expressive face is intentionally minimal. Stereo cameras form large circular eyes for perception, while a separate e-ink strip and chest OLED convey emotion and information without complex mechanical facial actuation. That choice reduces mechanical complexity and cost while providing an intuitive human interface. Another lesser publicized detail is Apptronik's emphasis on force-based safety and collaborative control. Rather than achieving extreme dynamic feats, Apollo's team focused on robust force control so the robot behaves safely around people. Also, while Apptronik cites experience tied to NASA's Valkyrie program, that lineage is about knowledge transfer and team experience rather than Apollo being a direct Valkyrie descendant. Apollo is purpose-engineered for manufacturability and industrial use, not as a lab-only research platform. Finally, Apptronik has engaged design partners, for example Argo Design early on, to shape Apollo's approachable look, an often underappreciated element in robot acceptance. Looking ahead to possible future developments and impact. On the technical side, expect continuous improvements in onboard AI, better foundation models and task learning, e.g., via NVIDIA Project GR00T style approaches, finer dexterity in hands and wrists, longer runtime or faster battery swap systems, and more modular tooling that lets one hardware platform serve many roles. On the economic and societal side, scaled production. Apptronik's Jabil collaboration is explicitly about producing at scale, and even the idea of robots building robots could drive the per-unit cost down and accelerate adoption, that would broaden the set of workplaces where humanoid robots are economical. The impact could be transformative in supply chains and manufacturing productivity, but it will also raise important workforce, regulatory, and safety discussions: how to reskill workers, how to certify robots for safe human proximity in different jurisdictions, and how to ensure equitable benefits from automation. Apptronik and its partners appear to be positioning Apollo to be a commercially relevant entrant in that evolution rather than a purely academic demonstration. To close, a realistic summary. Apollo is not the fastest, most acrobatic humanoid on the planet, nor was it designed to be. It's the product of a pragmatic engineering philosophy that prioritizes manufacturability, safety, and real-world utility. It was developed by Apptronik in Austin, unveiled in 2023, equipped with human scale strength and force-aware control, sensor suites for perception, onboard AI compute, NVIDIA modules, and a design intended to be mass-produced with partners such as Jabil. Public cost targets aim at a future price in the tens of thousands of dollars per unit, commonly cited approximately equals $50,000 as a long-term goal, but early units are more expensive and the company has not released a formal catalog price. If Apptronik succeeds at scale, Apollo could materially change physically demanding jobs in logistics and manufacturing and enable new assistive roles in eldercare and beyond. But that shift will come with economic and regulatory questions that society will need to manage alongside the technical progress.